In this video, I will explain you what is motional EMF. As the name suggests, we have motion here and EMF, which means here who is producing EMF? A motion in the circuit is producing EMF. So motion is the cause that is making an EMF. Okay. So here we have a magnetic field into the plane, and there I have kept a conductor having a shape of C. Now see, this won't, if it is inducing an EMF in the circuit, that won't send current because the circuit is not closed. Now to close the circuit, I am going to keep a rod here in this way. Now the circuit is closed. Okay. Now to make an EMF, I am going to bring the rod from this position to this position. So basically I am creating a motion here of this rod from here till here. So from this position it will now come to a new position like this. Can you tell me, is there a change in flux? Yes, because when the rod was here, the total area is this. Now there is a flux linkage with the whole area. Okay, let's say the value is 5 initially. Now from that position, when I have taken the rod to a new position, now this has become the area. That is 5 final. So we know that 5 initial is not equal to 5 final. There is a change in magnetic flux linkage with this coil. So obviously that will produce an EMF in it. Now we will see the value and the direction of this EMF. Okay. Now we have the equation EMF is equal to minus d phi by dt, and this can be written as minus d by dt of flux. Flux is nothing but BA cos theta. Now see, here the area is this one, okay, and this is the direction of area. This one is the direction of area, and even my magnetic field is also in the same direction. So the angle is 0. So this will be cos 0, and cos 0 is 1. So that can be written as minus d by dt of. And one more thing. Let's say this length initially if it is x, and this length initially if it is L. Now I can rewrite it as B into, what is the area initial? L into x. Initial area is length into breadth. So L into x, cos 0 is 1. And out of that we know that intensity of magnetic field is not changing. That is into the plane, and that is the same value. And even this length is not changing. Oh, what is changing? The x is changing. Now this was x. Now this has become x minus delta x. So delta x is the change here. So now the new length is different. The effective length is different. So x is the value that is changing here. So except x, all other term I will take outside. So minus d by, so B and L I will take outside, d by dt of x. What is dx by dt? That is rate of change of position. X is nothing but displacement or distance here. In this case it is displacement, okay, or the total length. So what is time rate of change of length? That is velocity, right? See, dx by dt is equal to velocity. We have learned this. So I can rewrite dx by dt as velocity. So this will be VLV is equal to EMF. So the magnitude of EMF is equal to B into L into V, or BLV, yeah. And we have a negative sign here. That negative sign represents the direction. Now one question I have for you. If we have a cell in this way and it is connected with resistance, in which direction the current will go? From positive terminal of the cell to the negative terminal. But inside the battery, in which direction current will go? That is from negative to positive. So inside the source, inside the EMF source, current is going from negative to positive. Similarly, here current will go from positive to negative. So we can generalize that current will always flow from positive to negative. It can also flow from negative to positive inside the cell. But in circuit always it will be from positive to negative. Okay, now this is an experiment. I have a magnetic field here. Okay, now this is a rod, metallic rod. So metallic rod will be having lots of free electron here, right? Now when I am dropping it from this position to this position, what will happen? These rods are cutting the magnetic field lines. There will be an induced EMF, right? Now in which direction will be the induced EMF? See, now this inside we are having lot of free electrons, right? See, now when electrons are moving in a magnetic field, it's nothing but moving charges in magnetic field that will experience a force, right? See, electrons, let's say I have an electron here. Now the moment I am dropping, the electron is moving in this direction. Okay, so movement of electron in this direction can be taken as movement of positive charges in opposite direction. Now I'll apply Fleming's left hand rule. So this is direction of current and magnetic field is into the plane. Okay, so this is the direction of current, magnetic field is into the plane and the force will be in this direction. Magnetic field, current, force will be in this direction. So if force is in this direction, positive charges will move in this direction, but negative charges will move opposite to that direction. So electrons will accumulate here. Positive charges will accumulate here. Now, when I am connecting this across an external resistance, what will happen? What will happen to the direction of current when I am connecting it with an external circuit? See, this will now behave as a cell. Okay, now this will send a current from positive terminal to negative terminal in this way, but inside this the current will be from negative to positive. This concept is very important. So similarly, when I am taking a rod from this position to this position, there will be an induced EMF on this rod having a length of L, and with that induced EMF current will be going, but always consider this thing that inside the rod current will be from negative to positive because that is the source of EMF. Outside the circuit that will be from positive to negative. Very, very important. So accordingly you can give the value. But here this one is very important. What is the value of motional EMF? That is BLV. Okay. Thank you.